Welcome to MLOps Live, a podcast by Neptune.ai.
We host in-depth discussions where machine learning practitioners answer questions from other practitioners about one subject related to production machine learning and MLOps.
Tune in to get real-life stories, dirty hacks, and pragmatic workarounds from ML people in the trenches. Hello everyone and welcome to MLOps Live. I'm Sabine and joined as always by my co-host Steven.
Hi Sabine.
Hey there, Steven.
How you doing?
Hey. So we are joined today by Amber Roberts and we'll be talking about embracing responsible AI for ML models in production. Hi Amber and welcome.
Thanks for having me. Excited to be here.
Awesome. So Amber, you have a background in astronomy and astrophysics. So pretty heavy duty stuff there. And you were selected as a Carnegie Fellow at the observatories of the Carnegie Institution for Science. Can you just briefly update us on what that means? Because that sounds really cool.
Yeah, sure. Happy to. Yeah, so my background is in astronomy. If you notice, there's a lot of folks with physics and astronomy backgrounds actually in the ML space. And I think a lot of that has to do with wanting to solve those big problems. And then I did my master's in Chile in South America. That's where all the telescopes are. They're in the Atacama Desert. If you ever get a chance to go to Atacama and kind of see the Milky Way galaxy, it's very cool. I highly recommend it. And then I got a fellowship at Carnegie in Pasadena, and that was a lot of fun. Pasadena is really like the science hub. There's Caltech, there's the Jet Propulsion Labs. So it's really like a fun place for astronomy.
Awesome. And I'm glad you highlighted this connection between, physics and machine learning, because I had thought to myself, can it really be a coincidence? But maybe it's not. You have transitioned more into the AI and ML space, right? You have worked at Splunk as a product manager and head of AI at Insight Data Science, and now you're a machine learning engineer at Arise AI.
So a lot of the work I do with Arise, even though my title is machine learning engineer, a lot of the work I do is around the educational component. So I really love science communication and science outreach in grad school. And I really love that I get that component with my current role at Arise. So a lot of it's the learning and development aspects and getting folks to understand ML observability and how to monitor their models with confidence in production.
We'll be getting into all of that good stuff real soon. We'll do a little bit of housekeeping here first. So pretty important announcement, especially if you're joining our live events here. As of next episode, we are changing the day to Tuesday instead of Wednesday, and it's 1 hour earlier than normal. So today is still Wednesday, of course, but as of next time, it's going to be on Tuesday instead, the live event. So make sure to change your calendar events if you've been tuning in. And of course, this recording here is going to be released as a podcast later on, so you can tune in afterwards as well. So it is a fully interactive Q&A session that we're doing here. Anyone who is participating live you can raise your hand to ask your question from Amber live. You can also just type in chat here in Zoom and we'll pick the question up for you. Yeah, I think that was all the important stuff from our end. So Amber, to warm you up a little bit here, could you define responsible AI for us to start?
Yeah, absolutely. I think the key thing to keep in mind when we're talking about responsible AI is to think about the foundations of what it means. So, empathy, fairness, transparency, accountability, because it's really the process of developing and deploying your models production in a conscientious way. We want to make sure that they scale well and also that they're being fair and are trusted with not just within our own teams and within our company, but our customers trust them as well.
This responsibility is not just about the model themselves, but also kind of how you operate around them.
Right. It's an emerging area, a bit more popular in Europe. There's a bit more compliance around AI, but it's not just the data aspects, it's the model aspects as well.
Awesome. So Steven, I think we're ready to head into the community questions.
Right. Thanks, Emma, for answering that. And I would love to know what's the relationship between like you, because at Arise, I think one of the things that core things that Arise does is like observability of models and data. But I would love to know what's that relationship between post-deployment monitoring as well as model explainability or things around building responsible AI models. So let's start on that premise first.
In terms of general responsibility with your models, a lot of teams want to implement a tool like Arise so that they can do the monitoring. And then, as you touched on, Stephen, like what's kind of broadly known as ML observability, which is an emerging area, very fast growing, a lot of momentum in the space. Whereas ML observability is going to be that post-production understanding of what is my model doing? How is it reacting with this new environment, with this new data? And so making sure that, you're using tools like drift detection, data quality checks, production checks, fairness checks, all in production, and then that you can then isolate those incidents. So the monitoring is kind of that red light, green light, and the observability should give you the understanding of where is this error actually in my data, and how do I fix it? So really focusing on that time to resolution.
How do those sort of eat into the meat of like responsible AI when we are talking about explainable AI, ethical AI and things like that?
So, I mean, the first part we tell all teams, like when they're asking that question, is like, best part is that you're asking that question. You are thinking about it, because with a lot of teams, like building responsible AI models isn't always top of mind. It's what metrics am I using to give the best performance? You're kind of thinking about it like on a quarterly basis, whereas responsible AI, like that's for the long term. That's making sure these models, are going to operate correctly, and new models are going to operate correctly in a way that's fair to individuals. The way we actually look at fairness. So fairness is separate from explainability, and I can kind of talk about the differences, but fairness, you want to be looking at essentially like a parity metric. So if you have a base group and you have a sensitive group, making sure that, recall parity, false positive rate parity, you're getting essentially a parity score between like 0.8 and 1.25. If it's outside of that, it likely means there's some algorithmic bias. So that's kind of the fairness checks, making sure that whatever you're predicting for like class A, like you're doing a good job on it and you're doing the same kind of job for class B. Explainability, and I always point out explainability because it's kind of like a buzzword in the field of ML observability, but explainability is going to be leveraging like feature importances for your model. And it won't actually give you any indication of how the model's doing. Like explainability, feature importance, SHAP values, they don't take into account whether or not a decision was correct, just what were the most important features into that decision. And so some teams, especially like fintech, may look at that explainability at an event level, which would be like a single loan, like why was this was the prediction, like what were the most important features that led to that prediction?
Right, quite interesting, and I think it sets a good tone for the rest of the questions that we have from the community here. We have an interesting question, and because in this podcast we talk a lot about reasonable scale teams, right? We want to ensure that we're focusing on small teams who are doing really cool stuff, and they're not doing Google style stuff, right? They're doing things that work for them. And in terms of like for reasonable scale teams, what should take precedence in terms of like the whole model management and governance space? Is it model explainability or generally responsible AI or post deployments model monitoring? What should take precedence pretty much?
Okay, good question. So you brought up like model governance and then the monitoring aspects as well. So sometimes it could depend on the country that you're in. There's different actual governance laws. And there's also there's data governance and model governance, but all really teams have to know is governance means we want to reduce risk. And there are various ways to reduce risk. One of the main ways that we reduce risk is the model monitoring. And that tends to be always the first step. First, knowing is anything actually going wrong before you can do an assessment on like the risk of your model. So there are certain metrics that you can use for that. But first seeing is my model operating as intended to in production?
All right. And this other team is asking, at the ops and functional level, can you walk them through what you see high performance small teams do after deploying models to production? But for example, I know at Arise, you're always working with small teams and, you're always hearing their stories, right? What do high performance teams do? And how is the setup like for model monitoring? and general explainability?
Yeah, so high performance teams, it's actually interesting. Like we were doing some onboarding last week at like Spotify, eBay, Etsy. So all these teams are high performance. I mean, like if you have like a team dedicated for ML at your company, you're already operating at a certain level. But the things we notice most from these high performance teams is that they're trying to automate the processes that are tedious, and they're automating the processes that will then help them shorten that time to resolution. So a lot of teams, have that, build versus buy. They want to look at like different vendors, like think about doing it in-house. But like the high performance team, they're leveraging tools where, they don't have to spend 2 weeks trying to figure out, is this model underperforming? It is underperforming. Where's that error coming from? Like going through all the data, they're getting alerted to that right away. So they could focus more on the critical thinking questions, the big questions, like how is this relating? Like, okay, I'm aware, I see everything that's going on in my model. How can I make it even better? How can I leverage these aspects? So they're really just automating the processes that are kind of a time suck. That time to resolution. Arise actually did a survey of over 1,000 ML companies. And what we found is, I think it's like 85% of teams say that it takes at least a week, normally 1 to 2 weeks, to even know there's an issue in production, and then an additional week to actually fix it. So if you take that time, condense it into a few hours to actually identify and resolve those issues in production, that's where you get those very high performing teams.
That's good. And just to follow up to that, could you give like a simple blueprint for how such teams monitor the models in production?
If we want to keep it as simple as possible, it's like you have your model. Your model is either going to be for a use case that has fast actuals or actuals that are very delayed. So setting up data quality in production is always the first step, making sure the data that's coming in, that's in your inference pipeline, isn't going to break your model. And then accounting for drift, because drift you can detect on any kind of model. Like, is your data drifting? Are the predictions drifting? Do you have concept drift? So being able to focus on that, like, is the metadata drifting? You can see that from any type of model, and it's the best proxy to performance unless you have those performance scores. So lastly, like setting up your monitors around performance, the actuals you do have, those ground truths, and then going from there. So that's kind of the simple blueprint of where teams like want to start.
Have you seen teams monitor fairness and biases? If you could give a use case example, that would be great.
Yes. Then so when teams want a way to do bias checks in production, they normally do use a tool like Arise. We have bias tracing, which is very similar to our patented performance tracing. And the way this works is being able to compare two different environments. So you can look different validation sets, training sets, and you can look at your training versus your production data. And so an example of this is, making sure that if you have a feature like gender, you're able to like do a comparison of environments, and you're able to look at male versus female, male and female versus non-binary, making sure that your parity again is close to 1, that you're making decisions fairly. And if your model is not good at predictions, or it's not that good, that might be fine. But as long as it's equally bad for both parties or equally good for both parties.
Right. And, one thing again about small teams is that barely all small teams can afford to use like pick up a tool and stuff like that. Have you seen a situation whereby they actually at this level 0 where we don't want to use any tool, but we know for sure that this is important? Has there been any scenario where they've gone on to like, say, hey, look, let's like do a bit of data slicing or something like that, and without any tool, and they did it successfully?
So, it's interesting you say that. And Sabine, I think I gave you a few links with the Arise platform. If they are like smaller teams, we do have a free version that offers bias tracing. And Savannah, I would like that you mentioned the slice level, because we actually look at it at the cohort level. So we look at the features, we look at inputs, and then slices kind of for numeric values. So we have teams all the time saying like, hey, this is important to us. We're not at the enterprise level yet. We maybe have one model in production, or we're looking to put a model in production. And so we highly recommend they just try out our free version. They can even put their own data into the free version, and they really enjoy it. And we enjoy the feedback too that we get, like what they're using it for, their use cases. So it is like very beneficial. And we really just want teams to leverage this bias detection to make sure their models are working optimally. Thanks, Sabine, for dropping those links. Sabine also dropped the link for the Arise community Slack channel, which I mostly maintain. So if you have any questions, if you're signing up for a platform, if you want to get your own data in, there's the platform support channel. So I'm happy to like go through it with you, help explain like what these things mean, the implications, and just get you like onboarded to that. I see we also have a question from the chat.
Yes, we have a question from Mateusz, who's digging a bit deeper into the fairness aspect here. So he's asking, what are features that can often be important for fairness other than obvious male, female, age, ethnicity? Is there a good procedure for finding them?
So, and really it depends on the teams, like what teams say, like these features, we want to do bias checks on them. And so a lot of times they are, in the explicit space of like protected classes. But sometimes, I mean, you can use proxies, things like zip codes, for example, and make sure that you're making good predictions on those. It could be like marital status for like credit cards. We actually saw like there's a lot of churn around divorce statuses, which makes sense when you think about it. But making sure those predictions are fair, and then the way we do them, the best procedure that we've seen, and like what we implement in the platform is, like Steven said, like breaking it down at the cohort level, like the individual slices of data. So seeing, does this bias exist like throughout this whole like time chunk, or are we getting biased because we're seeing this new input in production that we didn't train our model on? A lot of times that causes drift and it causes issues with fairness, especially if it's a new input, if it's a new feature, and if your model hasn't seen that, it can't make a good prediction on it. So this is often when teams would export that new data, retrain their model with it, and then see if the fairness would kind of flatten out.
Very cool. Thank you. And thanks, Mateusz, for the question.
There's a question on structuring. And this particular question is, this particular team, is asking, how are teams that are great at model monitoring and explainability structured, who is responsible for what? Because I think one of the key things is that it's hard to know, okay, yes, we are monitoring now, then who is responsible for taking action? Who is responsible for when servers are down, or when, like wrong predictions, when you have models giving out wrong predictions, or generally when you're having problems with compliances? How have you seen great team structure that really help solve this problem of responsibility and accountability? Yeah.
That's a really good question. There's not like a correct answer for it. It's oftentimes the main issue we see is that there isn't set individuals responsible for these certain roles. A lot of that goes back to like what you were hired for, your job description, and a lot of those don't include the kind of governance aspects that we were talking about earlier. Normally, when a team does prioritize like responsibility for their ML models, and they come to a platform like Rise, then we do help say like, okay, so who's going to be managing this? Like who's going to be doing this? Like, and we help onboard those people to know what to look for. It can be very difficult because there's also like the data aspects and the model aspects, and like bias can kind of seep in anywhere. So making sure there's folks around the data, the data scientists, the data analysts, the data engineers who have best practices. And then there's the model builders, model developers who have best practices. And so it's very tricky, and it definitely varies from team to team. And it has to start kind of at the organization level. And then the responsibilities have to be kind of divided and clearly defined, which it's an ongoing process, and teams are still actively figuring that out.
I'm still thinking, what does monitoring look like at a small startup, a reasonable scale startup, versus a hyperscale startup like Airbnb?
Yeah, so monitoring really looks the same. I would say monitoring it's more varied based on the use case and actually the company size. So we do work with small startups with like 1 to 5 models in production. We do work with very large companies with thousands of models in production. And so the way it's structured is very similar. You're still setting alerts around data quality, drift, and performance in production. It's really the use case that has a lot of variation. So is it a structured or like unstructured use case there? Because there's a few subtleties about how you actually monitor that type of data, but it's very similar. And a lot of times at these larger companies, there's going to be machine learning engineers that like each kind of have their own model, or they're working on a few models. And so we organize it by like organization, account, and then space. As a machine learning engineer, if I was at a startup or if I was at a large company, I kind of have a very similar view where it's laid out for me, where I have my monitors set, where I can edit any monitors that I want. And then when a monitor triggers or goes off, I can then explore and kind of go into discovery mode and see like where that error is and why it's occurring.
And we have a question from the MLOps community, and this is Shri from one of the programs that was run in the MLOps community a while back. And this person is asking, consider the case when a customer finds that some of the model predictions are not as expected. How often in your experience is it the problem of the model itself, that's the hyperparameters, loss functions, and so forth, versus data drifts or data processing, or maybe even infrastructure issues?
Right. Yeah. So we definitely see both. And it can be very difficult because often the data and the models are intertwined. So obviously a model is only going to be as good as the data it's trained on, but then that data a lot of times will feed into it, or the outputs from one model will be the data and feed into another model. And so it continues to go that way. So the way we do it is when we have an error, we focus on like where it's occurring in the data, like what data is either like corrupt, a type mismatch, a change in cardinality, an underperforming area, or a lot of times like it does this version like need retrain. So focusing on where it is in the data and then seeing like, okay, is this an output of one model? Is this like the data at the core? So we do see all types of errors, but that's why we really focus on the data and then work back from there.
So Stephanie is asking also about fairness metrics. It sounds like most of the fairness checks are geared towards group fairness metrics, and she wonders whether you have experience dealing with groups that are not easily captured, such as multiple gender identities and sexual orientation, which can change over time and with cultural context.
Great question, Stephanie. Yeah, so, and what Stephanie is referring to at like kind of the group level. So there's group fairness, and then there's fairness of the individual. And group fairness, you can think of if someone's accepting like 100 loan applications, there's like proportionality aspects. Like, so I'm accepting 100 applications, or I'm approving like 100 applications, and I'm going to take 50 men and 50 women. So I'm saying like, oh, equal numbers, but that doesn't always mean fairness, because there could be more qualified men, there could be more qualified women, or they'll say proportionally. So there might be like, oh, there's 100 men, there's 70 men applying and there's 30 women applying. Like I'm going to take 70 men and 30 women. So it's like proportional, but is that fair? So there's group fairness, and then there's fairness like at the individual level. And that's something like accuracy, like how accurate is it for person A and person B? I really like that you mentioned like dealing with the groups not easily captured. And for that, we do grouping. So anytime we do fairness checks, like, so you can compare like male, female versus, like non-binary. You can compare multiple genders to like any base group. So you can do those groupings. It's the same with our performance as well. Like you can do groups of that, or like sets, and do that comparison as well. So it's not just of, one clear defined group. You can put together kind of a category of folks and do that comparison. Also, if these happen to be unstructured, like maybe they're unlabeled, we do embedding tracking as well. So if your embeddings do start drifting, you can account for those. Stephanie, let me know if that answers your question, or if you have any further questions on this. That's a really important topic.
Yeah, I had a bit of a follow-up question about this. You mentioned these best practices at the different layers of MLOps. So is this like trying to dig into these groups and how you define them? Would that be kind of like one of the best practices?
So I was just reading like Stephanie's reply. Yeah, let me know if you have a follow-up. but I missed the second part of your question, Sabine. Like you're talking about best practices and then what might be a best practice?
Yeah, just digging a bit deeper into what actually
Okay.
constitutes these best practices at the different levels.
So best practices. So first, it's the being proactive. A lot of teams do come to us kind of in a reactive setting where they've had an issue happen in production that was either like very costly or an issue where they weren't even aware of it until their customers started calling and saying, hey, I'm not happy with this. So that's really the first thing we want to avoid. We want to be proactive. We don't want customers calling and complaining. So we want to make sure like your monitors are set and you have a post-production workflow. We find that teams often spend less than 1% of time in that production setting, where a majority of the time is on that data curation, that model training, model development, and model deployment phase, which are obviously very time consuming, but we want to make sure people are equipped in that production window. So first, being proactive. And then the best practices are around, trying out different tools, see what works for you, and just thinking like what's really important for you and for your company.
And back to you, Stephen.
Perfect. Thanks, Sabine. Okay, we have yet another question from the MLOps community. And this person asks, when applying explainability and generally responsible AI methods in practice, are there important trade-offs to consider?
So, I mean, the trade-offs to consider, similar to like when you're building and developing your model, your trade-offs might be around speed, around accuracy, around pricing. So there's always going to be some trade-offs, and it depends on the model too, right? Like when you're looking at something like transparency of your model or interpretability of your model. Obviously, if you have a tree-based model, like you'll be able to understand it a lot better than if you have a neural network black box approach. So the trade-offs can be around that. I mean, if you look at kind of the Netflix competitions around recommendation systems, there are the recommendation systems that have the absolute best accuracy, but that some of these models are huge and very computationally dense. They're expensive. A million things could cause them to break. So a lot of times going with that simpler model, even if it's a few accuracy points lower, is actually going to be a better fit in the end. So there's always trade-offs when thinking about it. The important thing, though, to consider for ML observability is what are you not willing to trade on? And a lot of times for teams, it's like they're not willing to let an error go longer than a week without being detected. They're not willing to have their customers churn because of an issue they weren't aware of. They're not willing to let like a model become biased in production and have that affect customers. Like those are a lot of teams like non-negotiables, like we don't want this to happen to us. We want to be proactive, and then we work around that. And so we set really like conservative monitors, which maybe it takes more time. Maybe there's more people needed for those checks. But if those are your non-negotiables, like that's the trade-off.
Thanks, definitely non-negotiables.
Yeah.
Also, another question from the community, and this is from Matt, and he says, are there common debugging tricks, rule of thumbs, or best practices to follow when trying to combat the bias you've detected?
Right. So depending on the type of bias you've detected, like normally what we say for teams, depending on what you detect, is like making sure you're looking at it in the training data, because a lot of times what we see is if it's not in the training data, if you're detecting something that's in production and you realize your model wasn't trained in it, the first step is going to be, okay, let's export this data that we got in production. Let's retrain our model on it so we can make a best decision. If you find that the bias actually exists in your training data, that's a level deeper because you're going to need to kind of do an evaluation. There's going to be more stakeholders involved, and it's going to take a team effort to figure out like what should be done. But either way, what teams will do is if they notice that bias, they'll put a challenger model. They'll take down their current model, they'll put up a challenger model, easy check to see if that error is occurring in this challenger model. A lot of times they'll have a few options. They'll put in one that error is not occurring in, why they fix the current issue.
Yeah, we do have a follow-up question from Stephanie in chat. So, well, it's actually an unrelated question. So how do you help customers decide on the fairness metrics to use for a specific use case, and who do you usually involve in the discussion?
I think that's related, Stephanie. I think that's a very relevant question, actually. So In terms of helping like customers, so first, depending on the use case, what's really important for us to know is that, is this punitive or is it assistive? What I mean by that is your model making a prediction that's assistive? Is this something that like is college admissions, for example? And if, you're predicting like, oh, this person's accepted, this person's accepted, or is it punitive? Are you dealing out like a sentencing based on that prediction? Because depending on if it's assistive or punitive really depends on the metric that you want to optimize for. You want to make sure that you're being like conservative on the sentencing, and I mean you're also being conservative on the assistive as well, but there's clearly going to be different impacts for the folks that are affected by those models. So making sure we know what the model's doing. And a lot of times the teams that are working on that like already have specific things in place. Like the people that are involved in the discussion are the model owners, the model builders, and then often like a team manager. So the manager does have to sign off on it. And the model builder is going to be intimately familiar with the data, the use case, like what they're hoping to get out of it. But oftentimes when we have chats with the customers that are building these models are very informed, and they mostly care about making sure everything is working properly, but they've done a lot of critical thinking on their end before we meet with them.
Right. So are these assistive versus punitive like the only categories, or is it just kind of like the main categories that arise in this context of fairness?
I mean, there's a lot of different kind of categories. So when you think of data bias and model bias, so when you think of kind of the types of bias that can occur, you're dealing, and this might be a little bit longer answer, but it sounds like people are pretty interested in kind of the types of bias that get introduced, and then like what actually causes them. So I can go into that a little bit, because what we see a lot of times, like when we see data bias, a lot of times we're dealing with historical bias. Like if you've seen the different embeddings models, it showed like man is to woman as doctor is to nurse, which are word associations. But if they're trained on historic like articles, there's issues with that, and that's something like historic bias. Or if you Google astronomer or like astrophysicist, like there's going to be a few key ones that come up, and then probably like a stereotype like of a scientist. So looking at historic bias, measurement bias, so making sure that, like we talked about, models that are actually generating us like sentencing. So proxy measurements that predict likelihood of recidivism, or like likelihood that a defendant will repeat a crime. We want to make sure that sentences for different individuals are fair and no one's getting a harsher sentence based on like a personal attribute. Representation bias. This we've seen a lot where teams, like these are the ones that cause like a lot of the scandals, like Google's image tagging algorithm, like tagging darker individuals like as a primate instead of as an individual because of the training data. So making sure your training data is actually equal. So these are like some of the data bias that we see very commonly, and these cause a ton of issues, mostly for the consumer, but then the company now like has all these issues that they have to deal with internally. And this goes back to Stefan, like what you were asking about, like who's responsible for what, having those discussions beforehand and then resolving it. Sorry if that's like a little bit of a long-winded response, but it's incredibly important to think about like the types of bias that actually get introduced.
Not at all. Please just go for it. That's why we're here. So thank you very much.
Yeah, no problem. And then, I mean, there's also the actual causes of bias, like what's causing these underlying bias. And I think Stephanie was touching a bit on this in like her question. So when we have bias, a big issue of that is going to be the sample size. And this is also factors into the metric that we're using. So is it assistive? Is it punitive? And then is there like a skewed sample of data? Like, do you have a really small minority group compared to the majority group? Same with limited features. Like maybe you have less important or reliable information in the minority group. So making sure that the data set is as clean, is as balanced, and there's different rules for like kind of that data set beforehand, that data governance side. And then making sure you're not having like a sample size disparity. The proxies that you're using, like you're aware of those proxies. For example, like you can be making a prediction and you're saying, oh, I'm not using any protected attributes. But if you're using something like zip code's a proxy to a lot of those protected attributes. So you want to be careful what proxies you are keeping in your data, because the data is going to find relationships no matter what. Like the computer algorithms are a million times more effective at identifying these correlations than we are. So like also being aware of these proxies, and that's where something like explainability could come in, because it's going to tell you the most important features that led to that decision.
So when you say you've used the word protected a couple of times, does that refer to like personal attributes or stuff that would normally be private?
Yeah. So when I say protected, I mean like actual federally protected group. Right. There's laws around you can't discriminate based on age, based on sex, based on race, on your political views. There's a lot on that, like veterans, pregnant women. So there's laws in place for that. So not only is it important for teams, it's their legal obligation to make sure things are in place if they're using those kinds of attributes. And that comes in a lot with healthcare, especially. They actually need some of those protected attributes to correctly diagnose and treat health issues.
Stephen, any community questions?
Yeah, perfect. We have one more question, or a few more questions that have been asked in the community. This person would like to know how you think about explainability in the context of data and ML respectively. In the ML case, it's possible to look into why certain decisions are made, but in the data case, they can imagine explaining how data was created, maybe the lineage, provenance, and so forth, or even observations about the data. Now, do you see these two entities, that's explainability in data and the ML categories, separate domains, or are they pretty much the same thing?
Going back to explainability, again, explainability is going to tell you the most important features that led to a decision. It's not going to give you any information on like if that decision was correct. So it's not going to give you any indication on the actual performance of your model. That's really important, because sometimes teams will say like, oh, we want explainability. We want to know why my model's performing like this, which it won't actually give. I often have these conversations because I'm asking teams like, what is it you care about? And then we'll work back from that. So in terms of explainability, it is a really useful tool, like having feature importance. It helps with the triaging. So if you do see an error, it's like, well, I'm going to start with my most important features. Like I see this drift happening. It's happening in a really important feature. Most of the decisions based on that feature, I'm going to go investigate it because it's really important. It also does lend itself to that hyperparameter tuning of the model as well. Like, oh, this feature like has almost no importance to my model decision. I'm going to get rid of it. So the data and the model and explainability, like it's all connected, it's all intertwined. But really what teams say they want is that those data quality checks in production, because the data quality feeds directly back into your model. And they might be retraining their model. Larger companies every day, they're retraining these models, very large models. And what we don't want is bad data to get in and then corrupt that whole pipeline. Because just because something doesn't break doesn't mean it's operating as expected.
Right, definitely. Silent failures, spoken about them a little bit. And yeah, I think data quality is definitely a fairly underrated part of the MLOps hype or MLOps process. Thank you for sharing that. And maybe just shedding a bit more light into what this person is trying to explain. I don't know, I'm doing too much on that end, but I feel like when you're thinking about the concept of, say, responsible AI as a term, now, do you treat both the data and the ML model as separate entities when you're treating these, or as, the same entity when you're, trying to troubleshoot what's going on? Is this, does this meet compliance? Or because you mentioned data governance and model governance, are these two separate entities that should be treated as such? Maybe there's a team that handles this on the data governance side, there's a team that handles the ML governance side, the model governance side.
When it gets to us, since we're the production, monitoring. When it gets to us, like we look at the model and the data as a whole. So when you actually upload data to the Arise platform, you're uploading the inputs, the outputs, the features, and then training validation sets. So it's kind of up to the team, like if they want to put in the training validation sets, or a lot of teams will just have it all be production. And then they say like, hey, we retrain our models on this window in production. And so then we have that. I would say from the building perspective, there's going to be folks on the data curation side, all on that data side. And then when it actually gets to the machine learning engineer, oftentimes they won't even know what certain features are or what they mean. So it's important to have that communication between the folks working with the data and features and then the ones using that do predictions. Because if these are larger teams, once it gets to the machine learning engineer, they may not know what each feature is and be like encoded from there. So, but for us, the way we think about it is it all stems from the data. And so we actually do versioning as well. So we'll set up monitoring around version A of your model, version B of your model, version C of your model, every data combination and feature combination that you currently have for that model, so that we can isolate incidents like for that model version. And so for us, it's a lot of times on that production window because teams are most likely retraining on a window in production. But we look at, if you want a separate training set, if you want separate validation sets, we can use them often as like a baseline comparison to see if things have drifted.
Thanks. Another question from the community. And how would you go about convincing the value of responsible AI to the business or profit inclined C-suite?
So, I mean, a lot of the convincing, I would say, has been done for us by teams having these major issues that cause a splash in like global news and like even Hollywood movies that say like the AI is taking over. Like people want teams to be actively thinking about their data and their AI that they're putting in production. But I think I said earlier, like responsible AI is a long-term solution. This isn't quarter to quarter thinking about how it's doing. It's a long-term solution. And right now, like the US, the regulations on it, there's much more regulations on the data than there are the machine learning algorithms, but just getting a head start on it, because eventually it's not going to be like responsible AI isn't going to be optional. It's being cracked down on. No one wants models to behave erratically, and no one wants chatbots to be saying the wrong thing. So as we've seen, they do, and we've seen these issues happen like over the past like 10 years. So I think convincing them is saying like, what are you interested in? Profitability. Okay, if you want profitability, what's going to help with that? It's building models that are going to sustain practices, models that customers are going to trust and they're not going to churn from your company or your platform. And it's ultimately going to be profitable in the end. That's how I sell it to the C-suite. And the engineers, don't need as much convincing. They're all for the responsible AI.
Not all engineers.
Not all engineers.
People just want to build stuff and put it in production.
Well, especially if I tell them I'm going to automate the process of setting up all the monitors for them and then just give them the alerts. They're all for that. Absolutely.
And we have another question from the community. And this person is asking, I come from a software engineer background with about 11 years of experience and a few years as an SRE. So what's the difference between observability from an SRE world and the MLOps world?
So I'm guessing SRE is going to be a site reliability engineer. And there's actually an interesting blog post that our co-founder and chief product officer, Aparna, put out on like the different types of observability. Because when you hear observability, like there could be like network observability in companies like Datadog, which we use, like, understanding where the data is. And then ML observability is going to be that post-production understanding of the model. So there are different types of observability, some more geared to like an SRE, some more geared to MLE, some more geared to software engineers, data scientists. So when we say observability, like if we just said observability, people would have different associations with what that is. And even in the MLOps, there's going to be different types of observability people think of. In terms of ML observability, where SREs like might come in is around making sure things are easily integrated and scalable. So that scalability aspect, which I would say is a really tough problem. One Arise does incredibly well. That's the scalability with billions of predictions a day, making sure those are aligned. And then the integration aspect. No one wants machine learning engineers to say like, oh, I love this tool. It has all these features. And then it's a headache to integrate. So making sure it scales and making sure that it integrates, which every team should think about when getting an ML observability platform.
And also, how often should they be worried about the responsible AI side of things as an SRE coming into the ML ops space?
Honestly, like you shouldn't just assume that you have like responsibility in it. You should follow best practices, but it's really like your manager. It's top down in terms of like this prioritization. So, I mean, being an SRE is hard enough, making sure like you're meeting all your commitments. And I would say if you work directly on the data side, there's probably more practices that you have to do, but yeah, just doing your best. And then I think eventually there will be like responsible like AI training that goes out to teams.
I think we have a few questions more, but I think this particular one would be helpful for a lot of teams. And this person asks, unstructured model monitoring and explainability are some of the hardest MLOps areas to solve today. Can you walk us through how you would implement observability and then explainability for an NLP-based project in just a short amount of time that we have?
Right. I was wondering when the unstructured question was going to come up because, yeah, almost 80% of data collected every day is in an unstructured format. And it's really cool to think about. I think I talked enough of like the unstructured use cases, monitor drift, monitor data quality, monitor performance with performance metrics. With unstructured use cases like NLP, what we're actually doing is tracking embedding drift. It kind of depends if you have labeled actuals or ground truths for your model, because if you don't have any labeled ground truths, you probably won't set them on performance, but you can always check for drift. And we actually are working with the founder of UMAP, Leland McGinnis, on like Arise specific metrics to be used for these unstructured NLP use cases. Because it's one thing to just kind of like plot histograms with unstructured data. It's another to actually visualize, have like a visualization for a high dimensionality reduction technique. So have a low dimensional representation, being able to see the data, like you would click into the data, and we're currently like being able to isolate and then export that data to help teams label clusters in production. So really interesting area, the unstructured use cases and being able to track your embeddings through like a vector space.
Maybe for the other questions that haven't been answered, we'll try to answer them in the MLOps community, but I think we can end with some few practices, right? This person is asking, what are bad practices you've seen teams do in the wild when it comes to how they monitor and manage their production models?
Yeah, bad practices. I talk a lot about like what we like to see. So what we don't like to see, or what tends to be bad practices, and it's honestly no fault to the engineers, but it's when maybe like someone on the team says like, hey, just set the monitors yourself, build them in-house, especially around like data quality. Some teams, they'll set their data quality checks, essentially, like they'll say like, okay, just ignore the bad data, or set like a kind of a threshold with it. Like, oh, if it comes in and it looks like this, just automatically reset it to something else, which really causes data leakage, because you always want the raw data, but sometimes that data quality, those data quality checks, like it's not good data. It's not data you should retrain your model on. It might be a type mismatch, might be a cardinality thing. It might end up breaking your pipeline. So you do want to have these checks, but you don't want it to be at the expense of data that's going to be making important decisions. So just being very careful about those like data quality checks and what you're doing when you encounter that kind of an error.
I think we've exhausted quite a lot of them. The other questions will definitely be answered in the Neptune Slack channel in the MLOps community. So if you haven't joined, the link to join is in the chat. Thanks, Amber.
Awesome. Great. Thank you. Yeah. And if you have more questions on ML observability, on Arise, I'm happy to answer them in the Arise community Slack.
Thanks as well from my side, Amber, for coming on and being our telescope into the
Yeah.
space of AI responsibility. So yeah, you mentioned that there is the Arise Slack channel, there's the MLOps community Slack. So before we wrap up, are there other ways people can sort of follow what you're doing online, get in touch with you?
Yeah, you can also follow me on LinkedIn. I'm Amber Roberts 42. That's a hitchhiker reference. And our LinkedIn, we put out a lot of content. We're really focused on education in this space. I recommend following like the Arise blogs or just follow Arise on LinkedIn. Like all that content, all the workshops we're doing, future events will be on that LinkedIn as well.
Excellent. Thank you very much. So we here at MLOps Live will be back in 2 weeks, minus 1 day, because we're moving it to Tuesday, the live recording, and 1 hour earlier, so 5 p.m. Central European Summer Time, if you're tuning in. And next time we will have Adam Becker with us, and we'll be talking about Auto ML and MLOps. So in the meantime, see you on socials and on Slack. You can submit your questions in advance if you can't make it, and we'll pick them up here. Of course, you can also talk to us about anything else MLOps related on these channels and catch up with any previous episodes wherever you typically get your podcasts. So thanks, Amber, and everyone else, and take care. See you next time. MLOps Live is brought to you by Neptune.ai. Remember that you can join us live at the next event and ask your questions. And you can register at neptune.ai/events.
And then make sure to search for MLOps Live in Apple Podcasts, Spotify, Google Podcasts, and anywhere you get your podcast. Click follow and don't miss any episodes.
Thanks, and see you next time.